All right, let's see. Traveling straight upwards, strikes into a block of wood here, right? So here's before, right? And then we also ultimately want to figure out the highest height that it gets to. Okay, so let's do that. That'll be it's actually like a two-part problem, right? So first picture is, and then this block of wood sitting like here, right? Sticks into a block of wood. So this is 0.2450 kilograms. Here is 0.0068. Whoops. It's a problem when your zeros look like that's 0.0068. That's this number right here. Kilograms, right? So 6.8 grams. And it's moving upward at 392. Okay, now resist the urge to say that this kinetic energy turns into the potential energy of the bullet in the block. What we have to do first is solve for conservation of energy, right? So bullet and block will have a velocity of, let's figure this out, 0.0068 times 392 equals 0.0068 times, whoops, wish I could erase, plus 0.2450. There we go. Ignore these parentheses there, right? Times V. So now let's figure out this V. So 0.0068 times 392 divided by, and then these are the parentheses here, right? This and this. Ignore that. Okay, so that divided by parentheses 0.0068 plus 0.2450. So the bullet sticks in the block, and these guys are going 10 point. This is going 10.586 meters per second, right? Now the final question here says, okay, well, how high does it go? How high is this going to go before it stops? It's going to go up to some maximum height, right? And stop, right? So what is that height? And then what we're going to do here is use energy, right? We can say that 1/2 mv squared equals mgh, right? As we so often do in these complicated times, right? So 1/2 times 10.586 squared equals 9.81 times h. Notice that the mass cancels out, so we don't need to put the mass in there. So we square that guy, divided by 2, divided by 9.81, 5.71. So the height, this height here, is 5.711 meters. Okay, so that's the answer to the second question. Question number 4.